Live.
Yeah, go ahead and start your slideshow there, Jim. Welcome, everybody, to the second session of the 2020 Mid-Atlantic ChaserCon. Of course, instead of being live in person like we were last year and the year before, we're virtual this year for obvious reasons. But that gives us some opportunities that we didn't have, which, reaching out to a wider audience, even folks from not only out of the area, but maybe even across the pond, because last week we had some visitors from the UK. And it also gives us a chance to bring in be co-hosted by a couple of television stations. Actually, we're doing 3 different television stations. This week, we're being sponsored and co-hosted by NBC 12 or WWBT in Richmond. And we have as our co-host, the chief meteorologist there, Jim Duncan. So Jim, I'll toss it to you.
All right. Good morning to you all, and I hope you can hear me. We're honored to be involved this year in ChaserCon. Of course, the event is this is a year 3, I believe. Chris was saying that we're happy to be involved in the Gray Stations. Our team of Gray Stations here in Virginia, all involved with us this year. So, welcome to session 2 of Mid-Atlantic ChaserCon. We had, of course, today's session, if you missed last week's, it was just fantastic. Dr. Halverson with the derecho discussion. Well, this week we're talking about the tornado outbreak in North Carolina. We're going back a few years, and this is posted on our website. This is a picture from down in North Carolina. This was the Lowe's store that had significant damage down there on April 16th, 2011. We have the link to that on our website as well. But you can, again, see what we're going to be discussing today with Jeff Orrock. And Jeff is the meteorologist in charge of the National Weather Service down in Wakefield. Jeff has had quite a distinguished career, and I've known Jeff for a while, since he's been here in Virginia, and we've had multiple contacts, and just a great guy. He graduated from Florida State University back in 1994, and immediately entered the National Weather Service, served in Pensacola during the Hurricanes Aaron and Opal. Jeff then served in the Austin San Antonio office of the Weather Service from 95 to 1998. And his attention turned to tornado research. He studied local tornado outbreaks, including the Gerald, Texas one in 1997. And in 1998, Jeff returned to the Mid-Atlantic, serving the Morehead City and Raleigh Weather Service offices until 2011. And coincidentally, 2011 is when Jeff moved back up here to Virginia to the Wakefield office. But he did get to forecast Warren counties for countless tropical systems, including Hurricanes Floyd and Isabel. And again, in 2011, after returning here to Virginia, he dealt with our rounds of severe weather as well. But we're going back in time now to April 16th, 2011, and we're so happy to have Jeff with us. He's a native of Chesterfield County, attended Midlothian High School, graduated in 1990. He's always had family here in the Richmond area. And again, we welcome Jeff and thank you. And we look forward to your discussion today. Jeff.
Oh, thanks, Jim. And I'll go ahead and get ready to share my screen here. All right, let me get back into the Zoom. Yeah, so it's interesting. I know Jim was mentioning he's known me since I've been back here since 2011. Ironically, I knew Jim before that because I had the privilege of watching you on television when I was back in high school. I'm trying to remember what year you came, Jim. I can't remember it though. It was somewhere right around maybe my freshman year or so. I try to remember.
1981, I started.
Yeah, so that's right. So we're lining up. Okay. Yeah. So I can remember when you first came on the air. So I think I knew you before you knew me. I appreciate the nice introduction, and I appreciate the work that you guys are doing. Hopefully everybody can see my screen. I'll do a quick check on that before we move on. We're good. All right. So yeah, so the April 16th, tornado event. There's always tornado. There's always events, as meteorologists, that stick back in our mind that you go back to and sometimes replay in your head, and what days leading up to it, during the event, after the event. This is obviously one of those career events. I call it. I went through Aaron and Opal. You heard Jim talk about those. Those were beginning of my career events. Several events in Texas, Gerald, Texas being probably the pinnacle, working that event and then going out and surveying the 5 tornadoes that occurred after that, and really substantial loss of life with those tornadoes. And then moving back east with the hurricanes here, but as far as tornado outbreaks go, this is probably one of the larger tornado outbreaks that I've been involved in. I've been involved in a number of them, but just the scale of it, the number of tornadoes, and just everything that was done leading up to it, during and after this event. This event, took us almost 2 weeks or so just to get our hands around how much damage had occurred, and what actually happened there on April 16th. So we'll jump right into it and kind of talk about what happened that day. So this is just April 16th alone, 2011. It was a very, very, very long day. You definitely see most of the tornadoes that struck North Carolina really hit US 1 east, so kind of that central North Carolina corridor to the east, and we'll talk about why that was. You do see a few spotty tornadoes here in the west, kind of just southwest of the Triad, and a little bit here in the northwestern part here near Roxborough, North Carolina. But by far the lion's share of the tornadoes really got going once you got to Highway 1, especially the bigger EF3s. It was kind of off to the races, and we're going to talk about why that evolution did that. In all, there was 24 fatalities on this day in North Carolina. Any day we lose folks is absolutely tragic. That's what we all train for, what we go to school for, how to forecast, warn, and then communicate the threat. The fact that it wasn't more fatalities is I think still a testament to the warnings, the media coverage, how much play this event got days going into it. Everybody knew something big was about to occur. This was on everybody's radar scope. A lot of folks were talking about it. A lot of big events actually had gotten canceled because of the forecast we had actually been working with, because this was Saturday. And so there was a lot of big events, early mid-April, that were actually festivals and things like that that had gotten canceled because of the high risk of severe weather that we'll talk about. So a lot of lives were saved, but we still lost 24 people in this event. As far as the fatalities, 13 of them did occur in mobile homes. There were 10 in what we would consider to be more stick-built, permanent type homes. I will say all of those 10 fatalities occurred up here in near Windsor, North Carolina. So all of the home fatalities, where you see the number 12, that's where those occurred. And we did have one person who was killed in a vehicle, and that was a person in Stanford, North Carolina. Overall, about 900 homes destroyed, 6,400 buildings damaged, 5 EF3s. A couple of them were getting very close to EF4 intensity, and we had 8 EF2s. So we start talking about significant tornadoes, EF2 and larger. There's a lot of these on this day. Even the Raleigh Weather Service office, which we'll talk about, was threatened by the tornado coming out of Sanford, North Carolina, moving up through Holly Springs, North Carolina. And so we'll talk about how that went down in the Weather Service office. As far as my office in the Raleigh area, we served 31 counties. So this was the breakdown of the tornadoes that I worked that day, everywhere from Alamance County and Person County in our northwestern warning area, Stanford Raleigh tornado, which was in the central part. That eventually became the Roanoke Rapids tornado. That was the same storm that hit Wake County, also hit Roanoke Rapids. The Fayetteville Smithfield tornado. I'll also make a note that my family was in Smithfield, so they were sheltering at the same time. Got to make a couple quick calls down to them, basically told them when the storm was down near Fayetteville, they needed to get somewhere really safe really quickly. So just kind of a big threat overall. The micro Johnson County tornado, getting up towards Wilson. And of course, later on, we have the Cumberland-Sampson County tornado, the Wayne County tornado, and that's the same storm. And that's eventually the same one that goes up into Birchie County and kills 12 people up there in Birchie County. And so we'll talk more about this. But this was the event that, as we worked it, the tornadoes that we were involved in and warning for and also surveying the following days. So looking at kind of North Carolina in general, and I worked in North Carolina, you heard Jim say from 1998 to 2011. So I was there for quite some time. I was always there as a warning coordinator. I was a warning coordination meteorologist in Morgan City, and then I was a warning coordination meteorologist in the Raleigh office. So I spent a lot of time there working with emergency officials, with planners, local and state levels. And one of the things that was very interesting was really the tornadic climatology of North Carolina. And there's really kind of a secondary tornado alley that extends from Alabama up through Georgia, South Carolina, and it comes up the I-95 corridor and east, really kind of just in the eastern part of the Piedmont, east of the Piedmont, kind of getting into that coastal plain area of North Carolina, where we do see a lot of enhanced tornadoes, a lot stronger tornadoes, and also longer tracks and more tracks. Has a lot to do with probably the moisture setup, the increase in instability, maybe with the sea breezes and other boundaries and things that set up in there. We get the Piedmont trough that sets up a lot across the central east part of the state. So there's a lot of factors that come together really in the central part of North Carolina and really just to the east into the part of the coastal plain where we do have, I'd say, our little mini tornado alley there for North Carolina. You do see another semblance of it here as you get from the Triad, Greensboro, Winston-Salem area back down towards Charlotte. This is another corridor where we do see, I'd say, more frequent tornadoes than other parts of the state. And again, it's kind of extending up out of South Carolina. We would kind of see the storms redevelop and reorganize a lot of times as they fell off the mountains and they started to move east. Sometimes we get moisture pooling on the east side of the mountains there, and that would help increase the instability, increase some of the moisture availability. And so a lot of times we would see storms sometimes intensify there in the Triad and down towards Charlotte. But by far the larger area that we see tornado enhancement really is, I'd say, John, kind of along the west of I-95 into the coastal plain. And you look at some of the past outbreaks, here's 2016. You can kind of see how it hits the hot zone there in the coastal plain. 1984 was another big year for outbreaks of tornadoes. You kind of see again, kind of in that coastal plain. 1992 was some very long track. This was actually an EF3 there from the coastal plain into northeast North Carolina. And again, back in 1998. So there is a hot zone, I'd say a favorite area for tornadoes in North Carolina. And this day, it was no different. Days going into the event, back on April 12th, as I'd say, when I went back and looked at some of our products and things that we did and the briefings that we provided at the Weather Service office and also from SPC, back on April 12th is when we were really first mentioning that there was going to be a potential for tornadoes. It was mentioned in our area forecast discussions and our hazardous weather outlooks back on the 12th, talking that about the 16th being a potential severe weather day and the potential for tornadoes, several days in advance. By the time we got to the 15th, the day before the actual event, so on Friday morning, we were putting out statements and briefings. At that point, we were in a moderate risk of severe storms, and the wording that we were using on Friday was basically forecasting widespread damaging winds, very strong tornadoes, and really kind of expressing the fact that Saturday was setting up to be a very textbook large-scale severe weather event. Meteorologically, kind of not going too far into the meteorology, but we had a very deep upper trough that was making its way across the deep south. It had been causing a lot of severe weather across the deep south. It was eventually going to lift up into the mid-Atlantic. We had a coupling of the polar and subtropical jets, so we have a lot of very strong upper level divergence, a very powerful low level jet setting up, basically pulling the moisture out of the Gulf of Mexico. In fact, this map here on the far right is your 925. So that's a 925 millibar map showing you extremely deep low pressure, way to the north near the Great Lakes, and just this huge moisture feed coming up out of the Gulf of Mexico. So very, very strong upper level support, a very forecastable type of an event. For day two back then, we were at a moderate risk, 45% probability of severe, and we were hatched, which means that it was significant severe, expecting, EF2 tornadoes or greater, winds in excess of 70 miles per hour and potentially even a 2-inch hail. But the focus here really was on the EF2 with greater tornadoes and really widespread potential of greater than 70 mile per hour wind, so widespread wind damage. By the morning of April 16th, this is Saturday morning, we were really anticipating, a very large event. We all knew that we were into something that was going to be, probably a career event for a lot of us. We were in a very rare high risk, so they really pinpointed the area there from really US 1 to Raleigh and those 995 corridor into the eastern part of the state as a high risk of severe weather. The moderate risk went almost all the way back to the Triad. of North Carolina. 30% probability of tornadoes, and the 15% prob again went all the way back to the Triad area. It was still hatched. You see those little blue hatchings there. So again, EF2 and greater tornadoes were anticipated. This here is a snapshot of what the radar looked like as the supercells were coming through the eastern or central part of North Carolina. And if we go back to some of our WRF runs, some of our high-res model runs that we were doing locally at that time at the Raleigh office, now this is all centralized, but you see the WRF, the NMM here, really doing a good job predicting basically a line of storms coming into the central part of North Carolina with some very good organization. This was the 9Z forecast for 21Z later that afternoon. So this was the early morning run of our local NMM model, kind of showing a really good line coming through. The ARW version of the WRF, again, showing good organization, a little bit more supercellular in nature, which is what verified. But you know, everything was obviously pointing to the fact that we were going to be getting into a big event, and we were really playing it up, basically telling anybody with outdoor plans they needed to really be thinking about what they were doing. We were recommending that folks, you know, literally not stay in mobile homes, like just don't spend the afternoon there. Usually we recommended folks finding something alternate to do that day, especially if you lived in a mobile home. Again, a lot of events had been canceled. We had also been communicating with Seymour Johnson Air Force Base, Pope Air Force Base. They had events going on, a lot of aircraft, and so this was very, very high on everybody's radar that this was not going to be a normal severe weather day. This was going to be something really different that was much more dangerous. Meteorologically, as far as the setup was concerned, these are the maps from 19Z. So this was about 1 o'clock in the afternoon when things were right before things were really starting to get going. You see the mixed layer Cape, you're really starting to surge north into central North Carolina. So increasing instability, increasing southeasterly flow. So warming temperatures along with a lot of increased moisture in the low levels, and then, you know, cool pool aloft, really increasing the instability. The shear, which we'll talk about, was really increasing. Especially you see the, this is a 0 to 1 kilometer helicity. So this is how much shear and spin, let's say, we have in that lowest 1 kilometer of the atmosphere. And that's really the most important layer for tornado development, that lowest 1 kilometer in the atmosphere that's getting ingested into the updrafts that starts to create these supercells. So very high helicity, very high shear in the lowest 1 kilometer of the atmosphere. And you can see here, it's definitely set up just east of Greensboro and Winston-Salem. It's set up across Raleigh, and then all the way down towards Fayetteville and locations east to the coast. So the shear was there. The LCLs, the lifting condensation levels, basically tells us how low the base of the storm cloud is going to be. So when these updrafts develop, how low to the ground are these updrafts going to be setting up? And these LCLs were going to be down around maybe 750 meters or so. So what that tells us is that the base of the updrafts are going to be very close or low to the ground. And the lower that updraft gets, that supercell, the closer that rotating updraft can get to the ground, the easier it is for the tornadogenesis process to occur. So we've got low storm bases. We've got to have a lot of shear, a lot of instability. And the bottom right here, we have a lot of moisture surging up from the Gulf of Mexico and the Atlantic. That's going to be fueling these things. So just kind of a quick overview, kind of going back to our meteorology. If you guys have been through some of the advanced spotter trainings, or you've been through some of the modules that we have online, when we talk about CAPE, or convective available potential energy, what we're really measuring is really the difference between what is the temperature inside our updraft that's shooting up through the atmosphere compared to the atmosphere, the air temperature around the updraft. And so, you know, this is like a RAOP sounding or upper air sounding, and the red line here on the left represents the temperature of the atmosphere, and the black line represents the temperature inside our thunderstorm. So as our thunderstorm updraft shoots up and becomes saturated, if the core of that storm inside can stay a lot warmer than the air around it, obviously warm air rises. So as the updraft shoots up, and when we get the moisture that forms inside of it and it's starting to go upward, if the air around that updraft gets very cold very quickly, our updraft will actually not only go upward, but it'll accelerate. It'll actually have an upward acceleration. So the higher it gets, the faster it goes. And so when we talk about high CAPE, or high convective available potential energy, we're really talking about, you know, what's the temperature difference between, you know, the surface aloft, and as updrafts develop, you know, how cold of air is the updraft actually going to be being surrounded by, being impacted by. So when you get a lot of instability, you actually get accelerating updrafts. They become very violent, they become very dangerous. And so that's what we had this day. A lot of instability, meaning very, very powerful updrafts. The other thing that we had in place this day was a lot of shear. And there's two different types of shear. There's what we call the speed shear, where you get the increasing wind speed with height. And of course, as the wind speeds increase with height, what happens is as your updraft develops, the winds aloft get stronger and stronger and stronger. So instead of your updraft going straight up and then coming straight back down, the updraft actually starts to lean over. You get this tilt in your updraft. The reason why storms need that, these supercells, is it allows the air to go up in the back of the storm, but then exhaust and come down in the front. So the directional shear, excuse me, the speed shear allows the updraft to tilt over. The next thing we had on this day was actually a turning of the winds. So not only was the wind increasing with height, but it was also twisting as you went up higher and higher in the atmosphere. So this twisting is important because that's what sets up the overall shear in the atmosphere. And so what happens is, we have a southeast wind at the surface. Let's say we have a west to southwest winds aloft. These air currents are going in different directions. The wind speeds are increasing with height. And so now what happens is when we have a lot of instability and we develop these thunderstorms, these updrafts start to basically pull the shear and pull it upward into the vertical. So they take this horizontal shear, they pull it upward into the updraft. And so now what happens is you have an accelerating updraft pulling in this shear. The updraft starts to rotate. And because the updrafts are violent and they're actually accelerating upward, they stretch that shear out. They stretch out to spin. And you know how it's like you take a skater with their arms, you pull their arms in, they spin faster and faster. And all of a sudden you get these rotating supercells with mesocyclones, that very deep mesocyclones in them. And of course, spotters, you guys know once this rotation, gets beneath the base of the clouds, this mesocyclone starts to spin down towards the surface. We have these wall clouds form on the backside of our supercells. So very classic supercell type structure that we had on April 16th, very classic setup. And I won't spend too much time on this slide. When we're trying to forecast these type of events, we're trying to balance how much energy we have in the atmosphere versus how much shear. If we have too much shear and not a lot of instability, then basically the updrafts get torn apart. They can't survive. If we have too much instability and not enough shear, then the updrafts just go straight up and they come straight back down. So it's really a balance to get these things perfect, to get these supercells going. And this was a day where it was absolutely balanced. We had the high level instability, the cape, which was the power for the storms. We had the shear, which gets us into what we call the storm type, the tilting storms with the rotating updrafts, basically giving us supercells. Very low cloud bases, meaning very quick tornadogenesis processes. And of course, we had the moisture, because the moisture is the gasoline for the engine. Without the moisture, nothing's going to happen. This was the RAOB, the balloon sounding from Greensboro that afternoon at around 2 o'clock. I want to say it should have been an 18Z launch. And you can see a good bit of instability. You can kind of see here the dash line, your updraft temperature compared to your atmospheric temperature. And in fact, the instability was higher as you got further east of Raleigh. Remember, this is back in the triad near Greensboro, which was right on the edge of the higher instability and where the shear started. So the environment was even better than this once you got towards Raleigh and points east. You see a turning of the winds as you go higher, increasing of the wind speeds. I won't get too much into this, but this was our hodograph here in the upper right with our default storm motion. So you can see a lot of helicity here. And in fact, anything that was going to have any more of an eastward motion, you are really going to be increasing the helicity, the storm relative helicity for that supercell. So the atmosphere was primed. We knew it was ready to go. We were just waiting for things to happen. By about noon, the storms were starting to approach just west of the triad. Once you got into the triad area just east, getting towards Burlington, and let's say down here towards Ashboro, you really see how the line was starting to blossom. It was starting to get into the high instability, high moisture, and better shear. And so you really saw the line starting to expand, starting to become more intense. The updrafts are accelerating. And then by the time you got into the I-95 corridor right near the Raleigh area, you really start to now see individual discrete supercells forming, because the atmosphere is just so primed. It's so supportive of supercells that now we have multiple large tornadic supercells all developing simultaneously. And again, you really see where that best shear, Raleigh, North Carolina, kind of sitting here right in this part of the map. So the triad sitting kind of out here right on the edge. So you really see, once you got east of the triad into the central part of North Carolina, how much that shear really started to increase. And of course, the storm mode really started to migrate into a squall line and then quickly into a supercellular type of a nature. The PDS watch, particularly dangerous situation tornado watch, came out at 12:05. that afternoon. The line of storms was just west of Winston-Salem, just starting to push into that area of the better instability and better shear. And so a special tornado watch called a PDS watch was issued at around noon. That was going to go until about 9 o'clock that evening. And I tell you what, I was going to stop there and just to see if there was any questions about the environment and the setup. And then we're quickly going to move into the tornado evolution and the radar representation. So I'll pause and see if you guys have any questions.
Do we have any questions from either the YouTube or the Twitter accounts?
None on YouTube.
Yeah, I don't have anything from Twitter right now. Some activity, but no questions.
All right, very good. So obviously the atmosphere is prime. We know that it's going to be a rough day. This is a Saturday. Normally we would have about 2 people in operations, 2 to 3 people in operations. We had a staffing of 11 set for that day, people to work this event. We actually even also had the evening crew coming in as well. So by the time you got to about 4 o'clock, this number would have increased to about 14 to 15 people. But during the day, as the storms were developing, we had 11 people in operations. We had 3 main radar operators. So we had 3 people really doing all of the warning, issuing the statements. That's all they were doing, was just running the radar, issuing the warnings, and trying to keep up with the storms as they develop. So we had those 3 folks set. We had 1 storm coordinator that kind of takes into account the bigger picture of what's going on to make sure that we're covering the storms that we need to cover. Nothing's falling through the cracks. We're keeping up with the phone calls and the coordination going out. Also kind of helping to monitor the storm environment. So how are things changing and evolving? How is the warning process going? Are we getting reports where we're issuing warnings? And of course, they're making phone calls out to all of the 911 centers and emergency management and those type of folks too. Eventually, we had to have 2 storm coordinators because it just got to be so much with multiple supercells going on. I was one of the coordinators that day, and then another person joined me because it was too much for one person to do. A lot of these supercells were developing simultaneously, and so we were on the phone constantly, really honestly trying to call as many people as we could contact to let them know what was going on. And these we're talking about emergency management at the state and local levels. 911 centers is who we were communicating with. One forecaster was still doing the forecast. The aviation forecasts still have to go out. We have to keep the forecast on the webpage updated. The watches have to be updated. Tornado watch has to be updated. So one person still doing the forecast side of the house. We can't just drop everything. We still have to keep some things going because there are still important facets to the forecast that can't stop. We had 3 other people involved in nothing but phone communications, basically intelligence gathering, working with Skywarn, basically at an of these 3 people, one person also assisted kind of as a backup radar operator. So they were kind of helping to keep an eye on all the supercells. Do we have valid warnings out where we need it? Are we sending out enough updated statements? Are we getting reports of confirmation of tornadoes on the ground? So that person makes sure that radar operator knew that we do have confirmation of tornado on the ground. And so that way, when they're updating the warnings or issuing new warnings, they can get that information in the new warning. So folks realize these tornadoes are not radar indicated, they are on the ground. And they're also very large and very, very devastating tornadoes. And we had 2 Skywarn operators there that day in the office. Raleigh has a very really outstanding Skywarn program. And so we had 2 radio operators there, basically monitoring the radio traffic, the ham radio traffic across all of central and eastern North Carolina. I think they were also monitoring some of the scanner traffic coming in from the different 911 dispatchers. So we had a lot of intelligence, a lot of information coming into our office throughout this entire event. So again, this was here about, this is about noontime. The storm is just coming into the western part of the triad, the Northwest Piedmont and North Carolina. The PDS watch is issued tornado watch issued just a few minutes after this radar scan. As it pushes into kind of that more west central part of the state, the triad area, getting down towards even just east of Charlotte, line gets a little better organized, really starts to get its act going once it gets to about Burlington, not quite to Chapel Hill and down to Ashburn. Now it's starting to kind of organize itself. And then again, by the time we get to about 4 o'clock in the afternoon, it's really organized itself into very powerful, dangerous, discrete supercells, all going at the same time, all tornadic at the same time. So kind of just showing you kind of the radar evolution here as the storms were kind of pushing out of the Greensboro, Winston-Salem area. And, you know, just a kind of a nice little line of storms really starting to intensify here and develop. And by the time you get to the last part of the scan, you start to see the discrete supercells forming, one down here near Sanford, and the other one here coming up into what we call Hope County, Rayford area, which would become the Fayetteville tornado. And these are the two longer tornado tracks. These were the two EF3 tracks that we were working on. Other thing that you realize here from an office perspective is realize that these tornadoes are actually, these supercells are happening simultaneously. If you watch the end of that loop, not only do we have, you know, a developing, you know, deadly tornado here near Carthage going up towards Stanford and Raleigh, we had the same situation down here in Hoke and Rayford County going into Fayetteville. So this is why we really ended up having the two storm coordinators. I've handled the Raleigh tornado. I did all the communication and coordination for this one. And then we had another person really handling and focusing in on the Fayetteville tornado, because even though we're going to talk about them separately, in real time, these events were happening simultaneously. And also to throw into the mix, at the very last part of this scan, there's a tornado on the ground up here near Roxborough. So there's a tornado that's actually ongoing up here near Roxborough. And we know that by the end of this loop, we're about to get into maybe some really bad situations here for the Raleigh area and for the Fayetteville area, both metropolitan areas. So things are evolving very quickly. Tornado already on the ground with two evolving supercells. So this is the Sanford tornado. This really is the first big one of the day. It really set the tone for the day. You know, the Roxborough one was ongoing. We knew we had a tornado touchdown up there. That had just happened. And then we see this storm starting to come out of really kind of the western part of the state, trying to push east. And you really see the supercell starting to develop here. Really, this is in Moore County, North Carolina, just kind of Sanford sitting right here. So southwest of Sanford got this pretty decent supercell starting to form. At this point, we had a severe thunderstorm warning on it. Was just starting to show some really good broad rotation. Again, we got the tornado tracking up here near Roxborough, where the tornado warnings are in effect. This evolves very quickly. You can kind of see here the hook echo that goes across Stanford. And so we'll kind of step through this in its evolution. So the tornado actually begins down here. Let me back up one. In the southwestern part or eastern part of Moore County near Carthage. And so this here is the beginning of the circulation of what's going to become the Stanford tornado. This was about the time we issued, a little bit before this, we issued the tornado warning, really for Moore County getting up into Sanford. And so if I step through the evolution a little bit later on, we start down here in Carthage, a supercell moves up towards Sanford. And as it gets through Sanford, North Carolina, you start to see at the tip of the hook, a lot of very high reflectivity. At the same time, you really notice how the circulation, the Doppler signature here, the inbound and outbound velocities, how tight that couplet was. And at this point, you know, we come from Carthage. It had been a weak tornado and then really started to intensify as it got just east of Sanford. And at this point, this high reflectivity at the tip of the hook tells us that we have debris being lofted up to the point of the radar beam elevation, which was a couple thousand feet up. So at this stage of the game, we knew we had a very large, devastating tornado on the ground. And everything was being updated, basically saying, you know, large tornado on the ground. At this point, we hadn't gotten a lot of reports of damage yet, because remember, the damage right now is actually happening. This is where we're actually tearing things apart. But at this point, we knew based on the radar, we had a large damaging tornado on the ground, and was basically changing everything accordingly and calling the 911 centers and just telling them that we know that there's significant damage on the east side of Sanford. This is a video not too far from the Lowe's Hardware. And it was very difficult to see the tornado. I mean, it's out there. It's not rain wrapped yet, but you can kind of see a lot of rain around it. This tornado was cutting a very large path. This is, you can see the extent of the tree damage here. The width of the tornado was well over a quarter mile wide, to the point where we're getting into high-end EF3. So we have even well-built homes being knocked off their foundations, a lot of substantial damage. We had some homes just completely destroyed, mobile mobile homes were completely destroyed. We had one person killed in a vehicle, one person killed in a mobile home down here near Sanford, but a very, very, very devastating tornado. This here in the upper left-hand corner is a picture of the Lowe's hardware that you saw in the video. At this point, we weren't quite where we were, just shy of EF4. We were very, very high in EF3. The story here at the Lowe's hardware, the video that you saw, there was a person in the parking lot that could see the tornado coming. They ran into the Lowe's hardware store. They basically announced that there was a tornado coming. The person kind of in charge, the manager in the front of the store, recognized the situation, and they were able to get on the loudspeaker and really tell everybody to move to the back of the hardware store. Because remember, this is Saturday. There's a lot of people at Lowe's hardware. And so everybody moved to the back of the Lowe's hardware. The tornado hit the front of it. The front of the store collapses. The whole front wall is gone. The roof collapses. There was no fatalities here at the Lowe's hardware. And really it's because of the quick action. I mean, how well they were able to quickly respond and react to the tornado. This is just a little bit later on. In the bottom right, just past the Lowe's hardware, there's a, I think it was like an air conditioning facility where they built air conditioners here on the right. That facility has been completely destroyed. And then you see here this metal building system, which was a pretty substantial building. This was a steel metal girder type of a structure. And it looks like somebody literally sat on it. It was really severely damaged. And this was really getting us close to that EF4 intensity. We did have it reevaluated. I have some other folks come in and look at our pictures and videos, and we did keep it at a high end EF3, but it was very, very, very close to potentially being an EF4 tornado. Now, for kind of the track purposes, you know, Sanford's down here in the central part of North Carolina. At this point, the tornado is moving northeast. The Weather Service office is sitting right here, kind of on the south side of Raleigh. So by the time the storm got into the southeastern part of Chatham County, we realized obviously the storm's headed right for the weather office. And the Raleigh office is on the 3rd floor of a campus building. We have all glass windows. And so we knew we obviously couldn't stay there if the tornado was going to come right across campus. So we actually had a plan to move folks downstairs in stages. We had 11 people upstairs. And basically the MIC at that time, Darren Verkursky, started shuffling people downstairs very quickly. And the plan was it was going to be the MIC, which was Darren, myself, the WCM, and one forecaster who was Brandon Vincent. We're going to stay upstairs until the very last. And so what we made sure that we did is we had, this was actually the signature here that we were looking at, this tight couplet headed right for the office with this hook echo with the debris ball still being evident within it. And so we issued the tornado emergency for the city of Raleigh. That was already, we made sure that was in effect. Before we took shelter, we even issued an updated statement for the tornado emergency for the city of Raleigh. And then what happened is it was just us three upstairs. And I remember I was actually on the phone with Wake County at that time. I'd been able to get up with the emergency manager on a cell phone at home, and really literally was just telling him that we had a large tornado that was most likely going to cut the city in half. And then this was going to be a very devastating event. And I think I remember even telling them we were going to lose people in the city. And so they were quickly mobilizing their EOC, getting folks in. I believe I was on the phone making that call when all of a sudden Brandon Vincent looks up and he says, is that debris falling outside? And I remember looking out the window, and you could see some light pieces of like insulation, almost like snow, coming down. And then all of a sudden we started seeing some larger pieces of siding probably off of people's homes starting to float down. So at that point, yeah, we were like, okay, we got to go. And so picked up the phone. Blacksburg was already ready to take over backup operations for us, the Blacksburg weather office. And so I picked up the phone and basically said, you guys have it. And then we all went downstairs and sheltered for about maybe 10, 15 minutes. It wasn't very long. 10 minutes probably at the most, seemed like forever. Once the storm went past us, it passed about 1.5 miles just to our east. Once the tornado passed east of us, we came back upstairs and just resumed operations like we never left, and took it back over from Blacksburg. So Blacksburg had our operations for about, I'd say maybe 10, 15 minutes most. And they did update the tornado emergency as well. Once updating it when it was right over the center of downtown Raleigh, they put an updated emergency out saying that there was a tornado emergency with the tornado actually right over downtown Raleigh. So this was the circulation right as it goes through downtown Raleigh. You see the hook echo really wrap up. and go out to the northeast side of town. Here's the actual velocities as the supercell is going right through. Remember, this is a highly populated county. Wake County is probably the most populated county in the entire state of North Carolina. So major population center that this storm is going through. And what you're going to see here is just some video, if it works. This is actually taken from Skycam. I think this was WRAL, I believe, video looking, basically at the storm as it was coming into downtown Raleigh. Now, you can't really see the tornado, obviously, but you see kind of the supercell coming right at us with this huge precipitation shield. There were a lot of people that had time. People left their homes. People were trying to get up and get out west of us, west of town, which made us a little bit nervous because we didn't want folks stuck on roads. But we do know that some people were actually trying to get out of the city, which being a weekend, I think that probably helped. But if this had been a weekday, that could have been bad news for folks to get in their cars to try to outrun a tornado. But we were hearing about that. All of the museums downtown put people in the basements. Everything was sheltered. The state capitol moved everybody into the basements. So everybody knew it was coming. NC State had tornado sirens going. It was pretty crazy. The damage you see here was on the north side of Raleigh. Again, very high-end EF2, almost EF3, really EF3 type of damage to a neighborhood. So fortunately, the tornado actually weakened a little bit as it went through downtown. It was fairly intense as it passed east of the Raleigh Weather Office. It was EF2. It weakened a little bit as it went through downtown and then really started to re-intensify as it got out the northeast side of Raleigh, again, doing really substantial damage to even well-built homes on the northeast side of the city. We did lose a couple folks in Raleigh. They were both in mobile homes as the tornado came through on the south side of the city is where we lost a couple folks in a mobile home. And I could pause there. We're getting close for time, but I'll pause there to see if there's any questions just about the Raleigh-Sanford tornado. This was such a significant tornado that went through such a high metropolitan area.
Any questions from social media, folks?
Yeah, that was not specific to Stanford Raleigh, but it was earlier, Jeff. Someone has asked, what indications did you have that the initial line would become discrete cells?
Yeah, it had everything to do with the shear, the way that the shear was and the way that the initially it sets up as a squall line, and that's pretty typical for that environment. And then it evolves into really discrete supercells out of the squall line. And that really had everything to relate to the way that the shear was set up for the environment, the way that the winds were coming into the line. With that much rotation, that much shear, the speed shear initially allowed it to set up as a squall line, but then once it got into the environment where the atmosphere, the winds were really turning, and we had a lot of twisting in that lowest 1 kilometer of the atmosphere, that really allowed the stronger updrafts basically to continue to intensify, and they basically became supercells. And as they became supercells, it breaks the line up. You no longer have a true squall line. You have more powerful updrafts that are kind of taking over the line. And now you have discrete supercells, really about 5 of them all lined up. So it really had everything to do with that sheer environment once it got to really east of the triad, and the whole line really kind of evolved. And that was anticipated, that we were going to be dealing with more of a supercellular type of a nature as the afternoon progressed. So it had everything to do with the way the atmosphere was set up. And there's been some really good research done down at NC State about the evolution of these squall lines, into discrete supercells. Good question. All right, here, nothing else. We'll kind of keep going and plowing through here. So shifting gears, this was up here in the Raleigh area that we've been focused with the Raleigh-Sanford tornado, and again, it tracked about 60 miles. And so, the next day when we were tornado surveying, I started down here in Carthage and moved up towards Lee County, and then eventually up into Holly Springs. And I had another team start up here in Franklin County on the northeast side of Raleigh, working towards us. So And we knew we couldn't survey everything in one day. We knew that this was one of the most substantial tornadoes that we needed to survey, and it was 60 miles long. So we had two teams at either end attacking it, moving in. We did the same thing for the Fayetteville tornado. We had a team start down here near Rayford, another team start up here near Smithfield, and those two teams worked towards each other. And so by the end of the next day, we actually did have both of these, at least the large EF3 tornado tracks, at least preliminarily surveyed with kind of our intensity and our swath information. But the Fayetteville tornado, you'll notice the supercell is happening simultaneously with the Raleigh tornado. Again, so we have two major tornado events happening at the same time. Here's the radar loop as the storm is going through. Here's Fayetteville down here. So you can see the hook echo here. This storm was a little bit more cyclical, maybe not quite as consistent tornadic wise as the Raleigh-Sanford tornado was. It did fluctuate in intensity at times. But you notice here when it was west of Fayetteville, you see the circulation here on the Doppler wind signature, the storm relative velocity. And if I do a stop here, you see the hook echo, back here on the backside of the supercell. Very intense, tight circulation here with your inbound and your outbound winds just west of Fayetteville. And that continued on out to the north side of Fayetteville. Again, continued hook echo. Don't quite see the debris signature that you saw in Sanford, but again, still very, very, very intense velocities here with this supercell. So again, fairly long track tornado that stayed on the ground for most of its life. And again, this ended up also being an EF3 tornado. We had a couple of fatalities down here in this area. Very powerful, very, very devastating. You see the picture there of the mobile home in the upper right. This is the point where you're just obliterating any type of mobile home, even compromising well-built homes. Here's a business here that's been completely destroyed. The side of it's been ripped off. So very substantial, large, wide tornado with this one here. And in fact, this is the continued on. This is the Fayetteville supercell, continuing to move up towards Smithfield, North Carolina. Very tight couplet. And in fact, here you actually see two tornadoes, and there were two tornadoes on the ground simultaneously with this one supercell. We had a tornado over here and another one over here, but both associated with the parent mesocyclone, the parent rotation of the supercell. As far as where my family lived, that day I know I was calling them to take shelter, so we lived about right in here. So we got up underneath the hail and the rain of the supercell. I lived about right here, so we were very fortunate. The circulation for us stayed just to our east, but still an interesting event where you're trying to keep up with everything that's going on. Raleigh's got a potential devastating event, and you're trying to keep your family safe at home. You're realizing that it could be a really, really bad afternoon back at home as well as here at work. So those supercells do continue on. The Raleigh tornado touches down here near Roanoke Rapids. So we get another touchdown up here right near the North Carolina-Virginia border. Eventually it continues on and becomes an EF3 up here across the peninsula of Virginia and goes up into Gloucester, which we'll talk about. The tornadoes down near Fayetteville and the one that hit down near Bladen County eventually moves up in here into Windsor, into Birchie County. And just kind of a quick rundown of those. This here is the supercell. Maybe go back. This here is a supercell that's basically going up through Clinton, Goldsboro, Snow Hill that eventually comes up in here and becomes a Birchie County tornado. So it gives you an idea of how many supercells we were really dealing with that day, as many as 5 at one time. And so this was the track for the Birchie County tornado. It was the most deadly tornado of the day with 12 fatalities, EF3. 10 of those fatalities were actually in well-built homes, what we would call stick-built homes. Again, classic supercell. Very intense rotation going up through Birchie County, just north of Windsor, near a town called Askew. Very, very devastating tornado. Very rural area. It didn't hit a major city. The tornado was just on the ground for quite some time. It was very intense, very wide. A lot of the homes up there were older type stick-built homes. Not quite the code that we have today. And so, the tornado was really destroying some of these older homes. And a lot of the folks that perished up in Birchie County were quite a bit older, anywhere from about 60 to 90 years old. So these were older homes that folks had lived in for some time. They just couldn't sustain this much type of wind and were destroyed. This is up where I live now, currently, Smithfield, Virginia. This was a continuation of the tornado that kind of came up through the Fayetteville area. So this was what actually eventually became the Smithfield tornado. There's a picture of it there. Tornado tracks just to the south and west of Smithfield, Virginia. And so that was a pretty damaging tornado that continued out of North Carolina up into Virginia. And then this was really the big one for the day for Virginia. And this was a continuation again of the supercell. I believe this was the Raleigh supercell that came on up into Virginia, and it ended up producing an EF3 that crossed the river, went across the peninsula near Williamsburg, and then eventually crossed the York River, and then through Gloucester County. And this upper picture here is a picture of the Gloucester Middle School that was completely destroyed by the tornado. And really, you see numerous homes, and these are stick-built homes that were completely destroyed up in that area. So, you know, as bad as in North Carolina, a day we had in North Carolina, when we were done with the storms, Virginia was really getting devastated. And this Gloucester event, I'd say, was really the big last hurrah for the day for this tornado outbreak. And it was very devastating up there in Gloucester, as you can see, a very, very high-end EF3, really almost EF4 tornado. This was really right on the cusp of being an EF4. And so really to kind of summarize this, you know, the 6th to 16th of April was the last of really a couple-day outbreak. The entire outbreak lasted 2 days and 4 hours. As the upper trough swung across the deep south, everywhere you see the dots is where we had severe weather and tornado outbreaks. So you had it basically swinging with the entire weather system. And some of the worst of it was in the deep south, and then of course here in the mid-Atlantic. You know, everybody knew how bad it was going to be. You know, you never can tell exactly who's going to get the worst and exactly how bad it's going to be, but we all knew it was going to be a bad day, and everybody was really well prepared for this. And even though we did have 24 fatalities, again, the way that the warnings went, the way that we were prepared for it, the media coverage was absolutely phenomenal. The emergency response preparedness ahead of us was phenomenal. The spotter reports were amazing. Despite this event being so big and so fast, you know, sometimes you can get behind really quickly. It's hard to keep up with this much going on this quickly. And we really never felt like we were behind at all. And I think we were able to stay ahead of it. And I think the media was able to stay ahead of it. And I mean, because we did this, we were able to stay ahead of the storm. There's no doubt we all saved lives that day. You know, there was 38 fatalities total across multiple states through the 14th to the 16th. North Carolina had 24 of those fatalities, but again, this was definitely a day that could have been much worse. And so everything just came together perfectly. So I thank you guys for giving me a chance to talk about this a little bit and kind of flash back to my last big event before I moved up here to Virginia.
Thanks a lot, Jeff. I really appreciate this. And I know I'll check with our social media monitors to see if there's any questions, but I had a specific question about the tornado that was down, the Fayetteville tornado that went up near Smithfield, North Carolina. And you showed two tornadoes at the same time. Was one of them an anticyclonic?
I don't think so. I believe those were both. I know what you're asking. I believe they were both actually cyclonic tornadoes. I don't think it was an anticyclonic cyclonic pair. I think it was. They were both spinning. They were both anticyclonic tornadoes. Cyclonic tornadoes associated with the same updraft, if that makes sense. I don't believe there was one. Let me go back to the images. A good question. I didn't think one was anticyclonic and one was cyclonic, though. That's a good question. I thought they were both cyclonic tornadoes. And there's some really good video of the one that coming up. That was one of the ones that came up I-95 that had some great chaser video on it.
And while he's looking that up, are there any questions that came out of the YouTube or Twitter accounts?
Yeah, from my side of things, Eastern Chaser asked a question about, made a comment in question saying, and I quote, realizing you had a fairly limited time scale, was there much discussion regarding the issuance of the tornado emergency for the Raleigh-Sanford tornado?
It's not, I mean, as far as discussion, it was one of those things, you know, where, because I was involved in the coordination of that one. And I believe Brandon Vincent was actually issuing the tornado warnings, really good radar operator. Once we saw the debris ball in Stanford, and it continued to move northeast, and then the structure held together, and it kind of clipped that little corner of Chatham County. It was starting to move up into Holly Springs, and it was maintaining the really intense circulation. It was also maintaining the debris ball. At the same time, pretty quickly, we were getting the reports of the Lowe's hardware destroyed. We got reports of really just entire neighborhood down in Lee County that had been destroyed. So we were getting sketchy reports in, realizing that these aren't just, a roof off of a house or, some trees down over here. We were getting substantial reports that it was widespread devastation in some areas, and that there was a lot of people missing. We were just getting, it was just sketchy along those lines. We knew it was big damage. And so really, I want to say about the time it was getting right towards the Wake County line, getting not quite to Holly Springs, to give the city some lead time. I think Brandon just basically said we got to get a tornado emergency out for the city of Raleigh, and so we put that tornado warning out as a tornado emergency. And then as the storm got closer to Holly Springs, that's when we started to see the debris falling down, and we updated the tornado emergency with a statement, kind of updating the position of the storm. And then I do know that when we actually did shelter, and we went downstairs, the Blacksburg office issued another statement with a third tornado emergency wording in it that was updating the storm right as it was getting into downtown, because we were sheltered at that point. So the TV stations were doing a great job scrolling it, and I remember seeing someone just had tornado emergency plastered across the bottom. And so it's one of those things where it's very rare that we ever do this, and this was probably one of the most clear-cut situations where you would issue a tornado emergency, because you don't do it on a whim. But I think this was one of the situations where it was just kind of, you got to do it. There wasn't a lot to think about in this situation. So that definitely helped, I think, protect a lot of folks in the city of recognizing how bad that situation was going to be after what had happened in Sanford.
Jeff, I have a question. The Lowe's, you mentioned they were able to save lives, and they were able to protect the folks that were there when they knew this was coming. A place like that, did that establishment already have a well-placed plan in place, and how was that all coordinated?
Yeah, that's a good question. We talked with the manager, and we talked with the folks that were working that day. That was always their plan, was to try to move people into the back, kind of into the bathrooms. You just had the right person there at the right time. That my understanding, the way it worked is somebody literally came in and said, "There's a tornado coming. It's like across the street," and they got on the loudspeaker and told everybody to move to the back. So there wasn't they didn't put a lot of thought into it, which was probably a good thing. They just reacted and went with it. Of course, they already knew the tornado warning was in effect. You get the tornado warning, it's in effect, and a lot of folks don't take that cover right away, and then somebody runs in the store and says, "Hey, look, it's coming. It's right here," and then they just shoved everybody in the back of the store across the loudspeakers. And there's some video on YouTube you can find of folks inside that Lowe's hardware. But there's no doubt that action saved lives. You saw how bad the front of that Lowe's and the middle part of that Lowe's is. And one thing I've always done in my training is really stressing in these large buildings that have large roofs, like whether it's a Walmart or a Lowe's hardware or any type of big box store, you get these large expanse roofs, and instead of them flying off, what they do is they collapse into the structure. So we always stress the fact that you do not want to be in the middle of that, under that roof. You really want to get into a part of the building that has a lot of structure, whether it's back towards the back. In this situation, it was in the back because the tornado was coming to the front. But you want to get into an area where you just don't want to be under that large roof, because that large roof is going to collapse. So, they just saved so many lives by taking that quick action there.
Jeff, I have a question. So for folks that may not know how that works, when a weather service office that issues the warnings is impacted by the tornado that is headed towards that office, what do you do in a situation like that? And, how do you continue to, watch those warnings and continue to follow that storm when you have to seek shelter?
You mean as far as office backing up another office?
Right, exactly. Kind of go into detail on a little bit of that for folks that may not understand how that works.
Yeah, so I can probably stop sharing my screen. We practice this several times a year, and we're paired up. So meaning that certain weather service offices are paired with other weather offices. That way, if something happens to Raleigh, Blacksburg, knows that they're automatically responsible for taking over. Now, if it's something catastrophic, like you lose a phone line communication or something happens, the office just kind of has to spin up and be ready. In this situation, we were able to call Blacksburg when the storm was down in Lee County and say, look, this tornado is potentially heading right at us. We need you to be able to back us up. So what they do is they go into their forecast system. It's called AWIPS. And they literally just boot the system up as if they are us. And they have a direct connection to our radar data. And it's really configured as if they're sitting in the Raleigh office. And so they have their workstation all set up. They're calling up the radar data that they need. They can obviously see all the warnings that we're issuing. So they can look like they're actually sitting in the Raleigh office. So we gave them a heads up to basically say, you guys need to be ready. Once the tornado got to, I'd say, right into Wake County, maybe not quite the Holly Springs, I know I called Blacksburg up a second time just to kind of confirm. I was like, okay, you really are setting up a workstation. You're going to be ready to take us over, just making sure. And they said, yeah, we're just about ready. And I remember I said, the next time I call you, you're going to have responsibility. And so I hung up. Maybe just a little bit more time passed. This all happening so fast. And when we saw the debris falling, that was the last thing I did. I hit the speed dial, basically said, this is Jeff from Raleigh, you got it, and hung up. And at that point, they were already ready. They had all of our stuff up, and then they kind of updated. We had updated it to tornado emergency, and a few minutes later, they updated it again, kind of just trying to refresh the location of where the tornado actually was as it was going through the city. And we came back up. The tornado was probably on the north side of the town, as the city. So we were only downstairs. Like I said, it probably wasn't more than 10 minutes that we were actually down there. And of course, all of our systems are still running. So we just come back. Everybody goes back to where they are. We call Blacksburg up and say, okay, we're back. And then they just back off. But we do this a lot for hurricanes too. Obviously, if our office gets hit by a hurricane, following Hurricane Florence, the Wakefield office backed up the Morehead City office for almost a week. Not because they went down, but because the staff was so beat up. A lot of them had damage themselves. They had been working really nonstop. Some of the folks had been in the office for about 3 days because they were cut off by flooding. And so it just got to the point where, for the health of the office, they went down, and we took over their responsibility for about 5 days until they could kind of catch their breath, kind of assess the damage at home, get families back in town, and then they came back up after about 5 days. So we're always set up to do this, to back up from one office to the other.
Jeff, quick question. When you came back up after when you've taken responsibility back from Blacksburg, and all your systems were still up, I mean, obviously you have uninterruptible power supply, but was the power immediate around you out at that point?
Oh, right.
It was.
Yeah, definitely. No, the power was definitely out around us. The tornado had hit only about maybe a mile and a half on called South Saunders Street. So, which was actually the exit that I would take to get to work. I'd bring up the route there, 440, and get off on South Saunders, and then that takes you right into the weather office. So, really, the next exit over was the one that had gotten hit by about an EF2 tornado. So, and you could even smell the pine smell. You know how after a tornado goes through, you're pulling in the outside air, the ventilation and stuff. And I do remember going back up there, and you could actually smell. He had that pine tree smell even in the office, just from the air that we were, kind of recirculating from outside. So obviously you knew that tornado had just passed, pretty close. You get that if you've ever gone through something like that, that heavy pine smell after a tornado goes through.
Any other quick questions? Maybe one or two. I know we're going over just a little over our hour here.
I just a comment. I love it that the Jeff and two of your other folks were like the captains going down with the ship. You were the last ones in the office. So with much respect for that.
Right. Well, Jeff, we certainly appreciate your time and your efforts to put this together for us and bringing us up to speed on something that happened almost 10 years ago now, and let us know the details. Jim, did you have anything else you wanted to end up with?
Yeah, I'm going to just kind of push ahead now to what's coming up now for the next couple of weekends. Of course, last weekend we had a great presentation, and Jeff, we loved your presentation today. This will be available to see, of course, via the website midatlanticchasercon.com. And the YouTube link can be found there. So this is kind of like a master class, I think. With the presentation was awesome. The kind of the setup that you gave, Jeff, on the conditions and the different parameters and such. And then, of course, what actually happens. So I think it's excellent. I think everybody in the business and storm chasers and everybody that's really interested in this should watch this. It's just so informative, and we appreciate it. Coming up, looking ahead, we have 2 more events. November 7th, next weekend. This will be hosted by our sister station, WHSV. Aubrey Urbanovitz, the chief meteorologist there, will host the guest speaker, Karen Kosiba, who is with the Severe Weather Research Center, and she will be presenting next weekend's talk, and that starts at 11 a.m. as well. And then the following weekend, November 14th, 11 a.m. to noon, Brent Watts with WDBJ will be hosting a storm chaser panel, which would include those folks there, including Peter Forrester. If you follow Twitter, you see a lot of Peter's posts. He takes excellent pictures, and Chris Jackson and Roger as well. So basically, a lot more coming up the next couple of weekends, and we invite you to join us for what will be the second half of Mid-Atlantic ChaserCon 2020.
Well, thanks a lot. I appreciate everybody's efforts, our social media monitors, and of course, Brent Watts in the background pushing the buttons for us. And Jim, thank you for co-hosting and for NBC 12 and their support. And certainly, Jeff Orrock, thank you for your time and efforts. And we look forward to continuing our Mid-Atlantic ChaserCon sessions next week. Bye.
Bye.